My name is Adam Lavely. I'm here on behalf of the Institute for Cyberscience. I spend half my time working for ICS, and the other half the time I have a postdoc-like position in aerospace engineering. There are several of us within ICS that do our own research, and so we feel your pain. And so I think that hopefully we'll be able to get you started, able to do your research on our systems or on other HPC systems. So to begin with, I'll give you kind of an overview of what I'll be talking about. I'll talk a little bit about high-performance computing in general. I'll be talking about how to get started on ACI. That's what I'm going to spend the bulk of today's talk on. And then at the end, we'll talk about some additional resources that you can use to move on after this. I'm going to be throwing a lot in the getting started on ACI at you, just so that you have the terminology. If you have any questions, please just raise your hand. I'm going to try to remember to repeat the question so we can get it on for the camera. We are being videotaped today. I'm not used to that, and so if I forget to repeat your question, please remind me. And I should mention, I have these slides available for you. You can download them and follow along today or at any later time. All right. So for this talk, you have 3 goals. The first is to learn about HPC in general. So high-performance computing is a huge field, a very large topic. We're going to talk about some of the various resources that are available to you, both here at Penn State as well as elsewhere. The second goal is to learn about ICS-ACI. That's the primary HPC resource that we have here at Penn State. And then the third goal is to learn how to get more information. I have a few notes here. The first is to expect to be overwhelmed. How many of you have used Linux, have used the command line before? Oh, quite a few, good. So those of you that have, you probably won't be overwhelmed, but the rest of you very well might be. There's a lot of information in these slides. The slides have a lot more text than I usually like to put when I'm giving presentations, but I want this to be a good record so that you can go back through and work through these things on your own time. And with that, experience is the best teacher that there is, right? If you just come to these presentations, you might have a good idea how to get started, but the reality is you're not going to be able to actually do your research very well before you get down, get your hands dirty, so to speak. Not really, we are computer people, but and actually do some exercises. So today, I hope that you really try to learn the terminology that we're using. Right? Google is your best friend. You're going to be able to look for different resources all over the place. And then I'm also going to be talking a little bit about some of the basic concepts behind HPC. HPC, as I said before, is a very broad thing. And so depending on what your research needs are, the HPC resources that you're trying to go after or are looking to send proposals into might look very different from anybody else within this room. With the experience as the best teacher, please spend some time playing and learning. But one of the things that I suggest to everybody is that they start by replicating an existing analysis that they've already done. Right, so I have a lot of people that they say, oh, look, I'm taking a new class, I'm going to learn something new. So they're learning both a new tool and a new topic at the same time. And I like to break those up a little bit, try to replicate an analysis that you already know the answer to, you've already been through the process. So that way, if you are having problems, you know that you're trying to look for a solution on the HPC resource and not a solution about your problem, how you're actually trying to solve your problem. All right, so what is high performance computing? It's a very ambiguous term. A lot of people use it in a lot of different ways, but the way that I like to talk about it is compute that is large. And with that, large can mean a lot of different things. So there's large number of processors. So in my own research, I study the effect of atmospheric turbulence on wind turbines. When I'm typically doing runs, I typically do a precursor simulation of the atmospheric boundary layer. In the past, I've done that on up to 24,000 processors. Right? So that's a very traditional view of HPC with a large number of processors. But that's not all that HPC is. There's a lot of people here at Penn State that use our computational resources within ICS for a large number of runs. We have some genomics people that do 100,000 different runs, each that are 6 seconds long. And so large can be the large number of runs. HPC can also mean large memory requirements. I mean, even though workstations are nice right now, if you get up above, say, 64 gigs of RAM, it's going to be kind of hard to fit that into your chassis. On ICS-ACI, we have the ability to go up to, half a terabyte on using a single processor. And that's pretty large, but then there's also other dedicated resources out there for large memory type runs. And so those can be something that can be done on HPC. Yeah?
The dedicated resources out there, are they at Penn State or elsewhere?
They are elsewhere, and I'm going to be talking about that, especially if you're really interested in the large memory. ACI-b works with the Pittsburgh Supercomputing Center. They have a new cluster that just came up called Bridges, and that's going to probably be your best place to go if you really are working on something very, very large for memory. Compute can also be large in terms of the storage requirements that you have. Right, so large memory typically talks about how much you have in RAM, how much data you're using at any given time, but you might also need a large storage requirement, right? If you have a lot of different cases, say for machine learning, with HPC, you have the ability to take advantage of, a lot of these huge network drives that you just wouldn't be able to have in your own personal computer. And then large can also mean large runtimes. So some people, for my own runs, if they run for about 48 hours, that's pretty good for me. We have some people here at Penn State that like to run for 4 or 5 weeks at a time, and you're just not going to be able to do that on most workstations or any laptops really. And so I have a few examples here of the types of fields that typically use large for all the different types of large that we've talked about. And I have down here poor coding, and it's a little bit of a joke, but not really. One of the things that a lot of people use HPC resources for is scaling up a little bit, right? So you might maybe be able to hire a postdoc and rewrite something so that it works on your own personal machine. But that might not be worth it if you can just put it on a little bit bigger machine and run there. And so poor coding is probably a poor choice of words for how that is. But when you're looking at how to do your research, you do have to think about the amount of manpower that would go into making sure that it would work on a resource you have available to you. And so you might just throw it on a much bigger resource and not try to optimize it if that's going to be able to get you your research done that you need to get done. All right, so now that we know what HPC is a little bit, I do want to make the statement very clearly that HPC will not improve every single computational process that you have. Right, so HPC is very good at some things, but it's not a magic bullet. It's not going to do everything for everybody. Right? So if your goal is to do research, your task is really going to be to find the right tools for you to do your research. You might not use the flashiest tools, you might not use the newest codes, but you're going to find something that works for you. And so when you're trying to choose a tool, and this isn't just for computation, this is for anything really, you need to find or build a tool that's right for your problem. But the problem with that is that typically the perfect tool, I like to say that the perfect tool only comes with a purchase order. Right? So there are so many different people with so many different needs out there, you might not be able to find something exactly right for what you need. So the other option is to find a multi-purpose tool that's very capable. And so here at Penn State, we have ICS-ACI, and that's what we like to call a very capable tool. So on ICS-ACI, we have a couple of different parts to it. So ACI-b is a batch part, so you're going to submit jobs. And so with that, we have high, standard, and basic memory compute nodes. And so you're able to take advantage of a lot of memory, not as much as, say, at Bridges, but a lot of memory on the high memory portion. We have ACI-i, which is an interactive system. And then right now, we're rolling out some different things. We now have an RStudio gateway that's available for people to use. We already have a couple of groups that are using that now. I know that they're working on the Materials Studio gateway and the Galaxy gateway as well. We have some GPUs that are up and running for a couple of specific groups, and we're putting on some more. They're actually up. Several of us internally are able to use them, but we don't have them integrated into our scheduler yet. ACI also has some different partitions. So I mentioned with the GPUs before, there's some people in, well, I'm not even sure all the different departments, but some different people grouped together to get some funding for CyberLamp, and so they take advantage of the ACI storage, but with specific compute to the types of problems that they do. And then ACI or ICS also hosts different resources. So we're in the process of putting together a LIGO machine. LIGO is the gravitational waves. And so that'll be run by ICS staff, but used for very specific purposes. Now, all this being said, we have a very capable tool, but there's also more than just that tool. So ICS can help you get up and running on other places around. So the National Science Foundation has, I think, 13 different clusters at 7 different locations around the US. They're called the Exceed clusters. Some of these are very specialized. So Bridges is a portion of Bridges is set up for high memory type runs. And we have an Exceed campus champion, Chuck Pavlovsky, who can help you get up and going with a starter allocation and help you through the process of applying for hours there. You can also get hours on Stampede, which is at TAC. I think that it's currently the 9th fastest supercomputer in the world. Penn State with ICS is also a member of the Great Lakes Petascale Computing Consortium. So Blue Waters is a very large machine at the University of Illinois. It's about 5 times the size of ACI-i or ACI here at Penn State. And so if you're doing very large runs, that would be an excellent place to get up and going. And then we also have some experience on the DOE machines. You can apply for different awards through the Insight program for the Department of Energy. And those are for very, very large runs. So for a lot of my research through my PhD, I was working on some DOE machines, and we only got starter allocations there. And we realized that even though we were running 12 or 24,000 cores at a time, we were still small fish on those large clusters. Now, I think one of the most overlooked resources within ICS is the people. So I'm a part of the engagement team as well, along with a guy named Chris Blanton and Chuck Pavlovsky. We all have PhDs doing computational research. We've all used clusters all over the place. I think that I totaled it up one time, and I used 14 different non-Penn State clusters through my PhD. And I'm not trying to tell you that to impress you, but what I'm trying to say is that we have a lot of different experiences in a lot of different places. So if you do have specific research questions, we'd be a great place or a great resource for you to get started. ICS also has an IASC center. And so that's primarily tasked with helping people get up and going on ACI, our own HPC resource. But that being said, all of the GAs that staff the IS Center do computational research of their own. And they're from 7 different departments across 4 colleges. So they do a lot of things that I might not have done in Aero, or Chris Blanton might not have done computational chemistry. And so again, that's a great resource if you have some specific questions. Yeah?
Offhand, do you know which 4 colleges?
No. Most of them are in engineering, but I don't remember off the top of my head, sorry. Sorry, the question was if I remembered the 4 colleges. I need to remember to do that. ICS also has some other staff and GAs that can help with some different things. And so one of the things that I want you to walk away from this presentation knowing is that even if we can't help you specifically with what you're doing, we'll at least get you pointed in the right direction. We have a lot of experience in a lot of different places. And so we can get you started along the right path. Okay, so now the bulk of the presentation today is going to be getting started on ACI-i. So the first thing that you're going to have to do is to sign up for an account. Just out of curiosity, how many people here have an ICS account now? Oh, a lot more than I thought. Okay, good. So I mentioned earlier that we have the IS Center that's primarily tasked with helping people on ACI. I actually worked within the IS Center, and so I know a lot of the questions that come in. One of the most common questions with signing up for an account is a student will try to list whatever their advisor's email address is. And you have to use their actual Penn State ID, right? The 3 letters followed by a couple of numbers. So that's something that a lot of people get tripped up on. After you sign up for an account, your advisor will get an email, and they'll be asked, do you approve this person? If they don't email us back, we call that implicit approval, and we'll get your account going after about 2 days. Now, if your advisor emails us back more quickly and says, please get this person up and going, we can get you up and going potentially even later that day, depending on when in the day we get that email. So if you're a faculty member and you want to get your students up and going, as soon as you get that email saying that they request an account, email us and we'll get them going a little bit quicker. All right, so the two systems that most people use are ACI-i, which is our interactive system, and I have the host name up top there. And ACI-i, it's an interactive system that's a shared system, right? So a lot of different people can be using the nodes, and this is available for anybody across Penn State to use. ACI-b is our batch system, aci-b.aci.ics.psu.edu. The batch system is what people traditionally call HPC, where you log into a single head node, or log into one of the head nodes and then submit jobs onto the compute nodes. Now, with ACI-b, anybody, any Penn State faculty, student, staff, can sign up and has access to what's called the open queue. Currently, I think the open queue you can run up to 20 processors at a time for 24 hours. And then if you need more than that, groups can purchase allocations to be able to have larger jobs that run for longer than the 24-hour limit on the open queue. Now, both of these systems have a common file system. And so if you log on to one, you can alter some files, log into the other, and those changes are visible to you. So with ACI-i, you can log on either with SSH, which is a Linux command, or with Exceed on Demand. I'm going to talk about Exceed on Demand here in a few slides. EOD is Exceed on Demand. I do apologize for putting the acronym before describing it. So as I said before, ACI-i is a series of interactive nodes. And so when you log on, you're going to be placed on a node based on the load usage on those nodes. And when you get placed on that node, you run your things right there. It's as if you're sitting on that computer. You don't have to submit jobs. You just run your processes. All of the ACI-i nodes are called ACI minus IC minus some number. So if you see that IC, you know that you're on an interactive node. Now, these are shared resources. So when people log in, you might be on with 20 other people at any given time. And so there's two ways that you'll be limited. You'll either be limited because there's a lot of people on it and it's a shared resource, so there's only so many CPUs to go around, or you'll be limited based on a couple of constraints that we've put on. So you can use up to 4 processors at any given time and up to CPU hours per process. Now the per process is important because if you have all 4 processors working on a single process, you have a limit of only 3 hours. There's also a limit of 48 gigs of resident memory. You can use a lot more than that if you're willing to go to virtual memory, which does get fairly slow, but still 48 gigs is pretty quick. So most people will use ACI-i for debugging, right? They're trying to get their process up and going. They want to actually view a GUI screen, something like that. A lot of people will use it for visualization as well. So each ACI-i node has a GPU on it. And so visualization is actually, well, it can be faster there than on ACI-b. And then, as the name implies, people will use it for interactive things. So there are some codes that you just have to have the mouse to click certain buttons. And so ACI-i is the best place to do that. You can do it on ACI-b, but it's going to be a little bit slower. Now, the shared resources, these limits that are available to you, you can do more than that using ACI-b with an interactive mode. And I'll talk about that a little bit more in Seminar 2 for those of you that want to come. But outside of that, if you want to do interaction, ACI-i is probably the place that you want to be. Now, ACI-b, you log onto that with SSH, and again, I'll talk about that in a little bit. There's no Exceed on Demand with ACI-b, and you're placed on what's called a login node. So when you're on one of these login nodes, you'll be placed there based on the current load, but there's really not a whole bunch of load going on with those. And you use those for submitting jobs. You're not actually going to run anything on the head nodes, on the login nodes of ACI-b. And so if you log in and you see ACI minus LGN for login, don't actually do very much there. I mean, if you bring up a text editor or something like that, you're just fine. But don't start your Python task or OpenFOAM task, something like that. Now, what happens on the login node is you will submit a job, and we'll go over that very basically at the end of this talk today. That's going to be the primary, that's the primary task for talk number 2, is talking about submitting jobs. But you'll submit a job from the login node, and then that will actually run on the compute nodes. So ACI-b has a scheduler, and it's going to take whatever requests that you have for your job and wait until those resources are available, and then run that there using dedicated resources. So those are not going to be shared with anybody else, with any other job, with any other task. And so it'll be considerably quicker than if you, say, try to run it on ACI-i, where there's 10 other people logged in also trying to run things. And so with that, you have to be very particular with what you're requesting in your submission script. You have to request something that's capable of handling the job that you're submitting. You'll use ACI-b primarily for production runs, right? Once you have everything up and going, you have your script ready, you're confident that your code is running, you can run big jobs, long jobs, a lot of jobs, however you do your production runs there. And then I mentioned before, if you need more memory or more processors or more time than ACI-i has, right, with these shared resource limits, there is a way to submit interactive jobs on ACI-b. So I'll go over that in talk number 2. If you need more information about that before that, send an email into the IS Center. We can help you with that. All right, so I mentioned that we have a shared file system between ACI-b and ACI-i. When you get an account, you're going to be given 3 different places: a home directory, a work directory, and a scratch directory. Okay, your home directory, it has a location that's given there, storage, home, whatever your user ID is. That's 10 gigabytes, and that's backed up on a fairly regular basis. Now, the home directory cannot be shared with anybody else by design. And so if you have some proprietary data, or data that for whatever reason other people can't have access to, you can put it in your home directory, and nobody else will be able to get access to that. And so because both it can't be shared and it's backed up, store all of your important things there. You also have a work directory, so that's in /gpfs/work/user ID, which is a little bit larger. It's 128 gigs rather than 10 gigs. It's backed up, although not backed up as often, and that can be shared. And so a lot of people will compile their codes in their work directory, or put things that they're actively working on or want to share with other people in their work directory. We also have a scratch directory, a scratch space. So that's GPFS, scratch, or user ID. And there's no limit on the size of files that you can have there. Right? You can have as big of files as you want, but there is a limit of 1 million files per user. So typically, users will, when they're doing their runs, they'll actually run things on Scratch. Right? You don't know how much data you're going to produce, and so you run things on Scratch. Once your run is done, you'll do whatever post-processing, gather whatever data you need, and then you'll save your data either back to work or to home. Now, Scratch is not backed up, but it is very, very fast. And so that's why we typically tell people to do their runs there and then store their data elsewhere. Because there is no file size limit, any files older than 30 days are automatically purged. So Scratch is great, but please don't store your files there. Almost every semester we have at least 2 or 3 people that say, oh no, I lost part of my thesis, and there's nothing we can do about it. All right, so a couple of notes about the file systems. Your work and Scratch directories will both have links within your home directory. Right, so I gave you the actual locations here, but you don't really need to remember those because you'll have links in your home directory. Now, groups can also purchase storage space. It looks very similar to work in how often it's backed up, but you can buy 5 terabyte increments. So we have a lot of research groups around that, rather than have one person that has all the data files, they'll purchase a group storage space and be able to share their files in that way. Now, ICS also has something that's called archival storage. So all the storage that we've talked about so far is active storage. Your home directory isn't very fast, or isn't connected in a quick manner to the compute nodes, but you can run everything there. Those are active storage things that when you're running jobs or doing things on ACI-i, you can interact with very quickly. There's archival storage, which is for long-term backups. I don't know what sort of funding agencies you get grants from, but a lot of them now have data retention policies, right? You have to keep this around for 3 years after the grant is over, or for 5 years from the beginning of the grant, something like that. So archival storage is perfect for that. It's much cheaper than purchasing the active storage, and it's backed up, it's thrown on tape. So I mentioned earlier that we have the ACI-b, ACI-i. We also have this data manager node that's available for data transfers. That's how you get access to the archival storage. It's very, very slow to actually get anything off of there, but that's how the archival storage works. You don't even have access to it on the compute nodes. Now, with the data manager host, that's actually also optimized for data transfer around campus using whatever command you want to use, rsync or scp. And then that's where we have some of the larger data transfer programs. For example, we have a couple of Globus endpoints there for transferring data around between different HPC centers. But again, don't leave your data on scratch. All right, so now that we know a little bit about the clusters, how are we actually going to connect to the cluster? In addition to this training seminar, as well as the others in this series, we also have a couple of, or some, what are they called, onboarding boot camps. The notes for that are given in this Google link up top. And so a lot of what we'll be talking about here with connecting to the cluster for the first time, they have pictures actually showing what it looks like. I have a few of those pictures, but if you need more detail than what I give here, that's going to be a great resource for you. But your ways of connecting are primarily through a terminal program using something like SSH, using some terminal emulator. So PuTTY is one that's very common for a lot of our Windows users. You can run it on Mac or Linux, but you already have the terminal program available there. And then Exceed on Demand is the way that you get a way to get graphical interfaces. You can get that in other ways, but Exceed on Demand is probably the best way to do that. So if you're going to connect with SSH, you're going to use SSH, your username at whatever host name. And so for the rest of this talk, whenever there's a command that you would enter, I have this kind of almost yellowish orangish box. I'm not sure what color you'd actually call that. And so in the top is what you're trying to do. And then here is the command that you're actually entering. So you'll SSH space your username. So mine is AWL5173 at the host name. So I listed the host name for all of the ACI-b, ACI-i, and the data manager before. But that's how you'd connect to ACI-b, and then how you'd connect to ACI-i. And so something that is important, if you're on a computer where your username is different, you do have to type it in. I tell people to type it in regardless of what it is, just so that they know. But yeah, you do have to use your username. And then when you're actually entering your password, depending on what program you have, it might just show a little box. Right? So even though you're typing things in, it doesn't look like there's asterisk, 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 like if you're typing your PIN number at an ATM. But you actually are entering your password, just hit enter. We get a couple of phone calls about that every semester. People think that it's not taking their password, but it is. It's just not showing up, that the little, or the X's, asterisks aren't showing up. All right, so Exceed on Demand is a GUI-based program. We have this for accessing ACI-i. When you do this, it looks like you have a Red Hat desktop available to you. The Google link that I have here is to a site on our webpage that allows you to download the Exceed on Demand client for Mac, Linux, or Windows, and then also some instructions there. I have just a few things about it here. So when you connect, you're going to connect using ACI-i. You'll put in your Penn State user ID and password. Be ready for the two-factor authentication. And then also, you're going to have a couple of options for the Xconfig and Xstart settings. I put here what seems to work well for anybody and everybody. There might be things that work better for you on your computer. I know that a lot of the Windows people like to use the full screen mode. for their Xconfig instead of one of the desktop modes. I have not found that to work well on Mac or the Linux machines that I'm on, but a lot of the Windows people love the full screen mode. But this tends to work well for anybody. That being said, play around with it. If you find something that you like better for whatever machine you're on, feel free to use whatever works best for you. Now with Exceed on Demand, you can only have one session open at any given time. So that means that if you're at work and you start an Exceed on Demand session and it's still up, you're either going to have to terminate that session or, well, you're not going to be able to start a new session on another computer. Now that being said, you can come back to a session, right? So when you have that window up, you could choose to log out or you can just choose to quit the program. So if you just quit the program, the session will remain and you can get back into it. That's not perfect. We have found that there are some issues with that. And so please make sure you save all of your data. And so if you're able to come back to a session, that's great. But you don't lose anything if you're not able to get back to it. All right. Using Exceed on Demand, you do have this GUI interface. It is nice. You look like you're working on a desktop, that it's your own computer right there. That being said, you still have to use the command line. We don't have double-click icons for the different programs to bring up. You still have to use the command line. The nice part about this is that I only have to give one training seminar about how to use the command line, and it works for both people that are connecting with SSH or Exceed on Demand. Okay, so in order to get onto the command line, we have to start the terminal program. And that's going to be done using Applications, System Tools, Terminal. So when you're using Exceed on Demand, that's probably the most important thing you're going to have to do. You can see I have a link here. I think that if you right-click on that, you can have a little link there so you don't have to go through the menu every time. But that's not done by default. So Applications, System Tools, Terminal to bring the terminal up. All right, so that's Exceed on Demand. From here on out, everything is the same, whether you log in with Exceed on Demand, have that terminal up, or you just log in via SSH. All of the functionality for our HPC is done through the terminal. Right? Everything that you do, whether it's, well, you can load up GUIs from the terminal, but you'll have to use the terminal to actually get those started. And there's a couple of things that we're going to go over today about the terminal, about the command line interface. And the first is that Google is your best friend. And the reason that I say that is that Linux, the command line terminal, that's not an ICS thing. That's not an ICS-ACI thing. These are pretty universal. There are some specific things with submitting jobs that are particular to HPC and then some that are particular to Penn State. But almost everything that you do on the command line, this is very basic stuff. I would highly suggest that you find some tutorial online that teaches the way that you like to learn and go through it. That's going to be the best way to learn any of this. We'll talk a little bit about what I call the command line framework so that you know what's going on. Then we're going to talk about man and banana. Those are probably the two most important things about the command line terminal here. All right, so what I have at the very top is what happens when I enter a command, right? So you have this command prompt, which I show in orange at the very beginning, and it gives you a little bit of information. So that tells me my username, and it also tells me the node that I'm on. And that's how things are set up by default. Now, with that being said, you can change that. I know a lot of the system administrator type people will like to put the current time so that they can see what time they entered a command. A lot of people will change it so that it says the name of the directory that they're in. If there's something that you prefer, you can change that fairly easily. And then we also, so with looking back up here, I have the command. So man list funds is a command that I'm entering, and I'm showing that in blue. And then I'm giving it a flag. I'm giving it an option, this -H. So when you enter a command, the command by default will do something. And then if you have some sort of option, let's say we want to tweak the output, we want to look at it in a slightly different way, we can tell the command that by giving it an option. Rather than have two completely separate commands for something that's very similar, we'll just tweak the output. Now we have the output that's actually given, and here I'm showing it in yellow. And then the way that you know that the command is done running and you're ready to do something else is that you have a second command prompt come back up. Right, so when you start to run your process, if you don't have that command come back up, it means that the process is still going on. There is a way to throw processes in the background, but we're not going to talk about that here today. So this particular command, mamlist funds, if you run this on ACI-b, will tell you the allocations that you're in, and then how many, by default, it'll tell you how many seconds are total in that allocation and how many seconds remain. But I use this -h flag. To me, seconds don't mean all that much. I'd rather look at things in hours. So I give it the -h flag to give you a slightly different output than what is originally stated. So what happens is that I enter this command, tell me the groups that I'm in and how many hours are available, and how much time is available, -h in hours, and it's telling me this. So these are the groups that I'm in. This column is the number of hours total, and this is the number of hours that are still available. And so at the very top, that's going to be what it actually looks like. But for the purpose of this talk, I'm going to represent that here. So instead of showing the entire prompt, I'll just show the $sign and give you whatever commands and flags are necessary. All right, so most commands come with a manual. I said that Google is your best friend, and I stand by that. But that being said, you can also use the manual that comes with a lot of Linux commands right there on the terminal. So for example, if you want to find out about the command du, whoops, so I apologize, this here in orange is incorrect. You're not finding the total and available allocation hours. But this is bringing up the manual for the du command. You can do that by man du. So whatever the command is, you can replace du with that. When this screen pops up, you can use the arrow to go up and down, and then Q for quit or exit. And learning how to read these man pages is actually a skill that's very, very useful, right? So Google can give you a lot of stuff, but you have to wade through a lot of things to be able to find things. If you can bring up the manual and find what you want, eventually it's going to be a lot quicker. They do take a little bit to get used to, just because they're all written the same, and it makes sense for the people that read like that, but for most people it's a little bit odd. All right, so the other thing that I want to bring to your attention is banana. Now I use banana, but really banana is just a dummy placeholder. What we're trying to do is to give the command an option that we know doesn't exist, so that it spits us back out all of the options that do exist. Right, so the man page gives you everything. You have to go through everything. But let's say that you say, all right, I know this command and there's some option. I'm sure that when I see it, I'll know it. I don't remember what it is, so I'm going to enter something that I know isn't a command. So I'll use banana, and then it'll say unknown option. So here are the options that are available to you. So this is great when you just need to jar your memory. And again, banana is a complete, it's arbitrary. You're just trying to give it some argument that you know doesn't exist. The person that I picked up this trick from, I can't use their dummy argument because it's not for polite company, we'll say that. And so really, use whatever you know isn't going to be an argument that works. I've only ever found one program. It was a genomics program that has banana as a valid argument. So for me, for the most part, I just use banana and go from there. So, all right. I'm going to go over a few very basic commands. This will help you get around when you first get started. By no means is this an exhaustive list. Please go out, play around, find some tutorial to work through. So ls is to list the contents of the current directory. Right? List all the files that are in the directory that you're currently in. pwd is print working directory. This is very helpful to tell you exactly where you are, the name of the directory that you're in, as well as it also gives you the path to get there. Now you can change directory. So cd is change directory to some other directory that's within the directory you're in. And then copy a file, copy cp. A lot of Linux commands are something like that, that makes sense when you just kind of shorten up whatever you're actually trying to do. So here I'm copying some file that's called log file to some other file. A lot of times people will put a date or some timestamp if they want to save something in one instance in time and then keep working on the original. right, so that'll get you around. Some of the other basic commands that I would suggest that you look at are MV for move, RM for remove, mkdir, make directory. Find can be very helpful. grep and awk, depending on what you're working on, can be very, very helpful. ID tells you some information about the groups that you're in. DU tells you a little bit of information about what all, or about the amount of data that's in the directory that you're in. Clear clears the screen. If you have a lot of text there, you want to get rid of it. env is something that prints out all of your environment variables. If you are having some issues, one of the things that when you email the IAS Center, they might ask you to do is send in the output of the env command. So that way we can set up our environment to mirror yours as closely as possible. SSH is very helpful. Well, SSH is going to be required to actually get onto some of the clusters. More, so more is actually a command, as well as less for looking at text files. And then another one that I find that's pretty helpful is history, which will print off the past 500 or whatever commands that you've entered. Now, on the command line, Linux also has some special characters that are very helpful. So the tilde is your home directory. So we saw that your home directory was actually, storage/home/your user ID. You can just use tilde to replace all that and not have to type it all out. The period means here. So if you're copying a file from someplace else to here, knowing how to put here is pretty useful, so you don't have to print out your current directory. The period means go up one directory. So if you're in some directory and you want to move up, you can do cd space period to move up one directory. Asterisk is the wild card, so it means anything. So if you do, for example, ls asterisk, it'll show you all the files that are in something, or in the directory you're in. But if you do ls asterisk.ping, it'll list all the ping files that you have in that directory. If you are Googling around, something that happens very often is that Linux commands do one thing, and very often when you're trying to do something, what you're really trying to do is a series of things. And so you'll see the pipe. So that's the shift, the key between the enter key and the delete key on a keyboard. And that means take whatever comes out of this command, whatever output is there, and enter it into the next command. And so you'll often, if you're Googling around trying to figure things out, you'll probably see that. And then the greater than sign means write the command to some output file. So we talked about ls being the way of listing all the files in a directory. If we do ls, the greater than, and then log.ls, it'll write all that output into this log.ls file, which you can bring up at any point in the future. Okay, so everything that I've talked about so far is just basic Linux, right? These are things that are going to be the same, just about anywhere that you go, any Linux resources that are out there, and there's a bunch of them. The module system is a little bit more particular, but again, it's not just a Penn State thing. Most HPC centers use what are called modules, and these allow for multiple versions of the same software to be available. So with ACI, we have what's called the system software stack, right? That's software that we've built, that ICS has built and put there for you to use. And so you'll need to load the module that you wish to use to be able to have access to that piece of software. So the way that you look at the modules that are available, you use the command module avail. Makes sense? Avail, available. You can also search for a module with module spider. Now module spider will actually search through all of the different families, and I'll talk about families on the very next slide. And so you don't, it doesn't, when you do a search for a module, it might not necessarily be available right now, but module spider searches through all the potential modules. Now there is a problem with module spider in that it looks for whatever you search for here. So if you are a user of, say, R, any module name that has the letter R in it is going to show up, which is really too bad. R is a great code. Should be easier to search for. And then once you found the module that you want to use, you actually load the module. So module load, say ANSYS 18.1. All of the modules that we have will have a version number, but there is a default. So if you just put module load ANSYS, it'll load whichever version of ANSYS is the default. I would highly recommend that you actually put in that number just so that you have a record of which version you're using. It's probably not going to be that big of a deal if you're on ACI-i and you're actually interacting with it, but if you submit a job and you want to, resubmit or change some parameter, you want to make sure that you're always using the same version of whatever software you have. So even though you don't need to put that number, the version number, I would recommend that you do that. All right, so I mentioned before that, that we use what are called module families. So what that means is that we have families based on the compiler type and families based on the parallelization type. So if we have a code that needs to be compiled, we could compile it with either GCC or with Intel or PGI. And so if we were to compile that with the GCC module, you would have to load the GCC module so that you have access to all of the different modules that were built with the GCC module. So for example, when you first log in and you type module avail, there'll be, 20-ish, 30-ish modules that are available to you. But then if you load the GCC compiler module, now all of the modules that were built with this GCC compiler are open to you. You're in that family. So when you do the second module avail, the output will give you something like, 45 or 50 different modules.
So if you run something through MATLAB, for example, would you need to load MATLAB first? That's not the same thing?
Well, okay, so MATLAB is a binary. So it's going to be available to you without loading GCC or Intel or anything like that.
Oh, okay.
That being said, there are people that do compilations of, MEX files within MATLAB. And so for that, you'll have to load one of the compilers for that to be able to work. And then load that same compiler every time you compile your MEX file. Or try to run. Yeah?
So this is different than if you use MATLAB to run another software that runs through MATLAB.
Yeah, that's it. Yeah. Yep. So I mentioned before with Module Spider searches through all the different families. And so that's how I recommend that you actually search for the modules. Module Avail will just show you the families, or all the modules that are available to you now with the families that you have loaded. Now some other commands that you might want to look at are Module List, to list all the modules that you currently have loaded. Module Purge, to get rid of all the modules you currently have loaded. So let's say that I load GCC, but I realize, oh no, I needed to load Intel. I can either do a module unload to get rid of the GCC or a module purge to just purge all the modules that I have open now. Now something else, especially for people that are compiling codes, something that's handy is the module show and then the compiler name. So when you load the GCC module, what it does is it adds a bunch of things to different paths, your path, your C++ path, your C path, and then it also gives you some environment or creates some environment variables for you. And when it does that, it allows you to have full access to everything that the GCC compiler has. When you're compiling code, sometimes you need to link to those specific libraries. So if you do module show, it'll tell you all the things that are done when you load the module. And what that does is it tells you all the locations where the important software to link to are. So for people that are actually compiling a lot of things, module show, whatever the module name, is very helpful. If you're not compiling things, that one's probably not all that useful, although it does tell you, the version number and a little bit about the software. But if you're loading the software, you probably already know what it is. All right, so just about everybody that uses our systems transfers data to and from. When you transfer data and how you transfer data depends a lot on your personal workflow. For example, I have a pretty nice workstation in one of my offices that I do a lot of my debugging on. When I'm ready, then I transfer a lot of data to ACI to actually do my runs. And once the runs are done, I'll do a little bit of post-processing there, but I'll bring it back to actually make a presentation or write a paper. So I do a couple of transfers. Other people do transfers in different ways or at different times within that process. And then you can also transfer data around between different HPC centers. So there's a couple of different ways to transfer data. Most people will use a command line tool like SCP, rsync, SFTP. When you're doing those, you can use Data Manager. If it's just for a couple of files, you can do ACI-b, ACI-i. It's all a shared file system, so it doesn't really matter. But Data Manager is really meant for a lot of data to be moved around. There are some local programs that you can install on your own computer WinSCP is a pretty standard one that a lot of Windows people use. I personally prefer FileZilla. FileZilla is available for all different operating systems. Use what you're comfortable with. There's also some different online methods. We have a lot of people that, for whatever reason, they're unable to transfer files in a different way. On ACI-i, we actually have the Firefox web browser available to you, and so we oftentimes will have people open up Box or Dropbox and transfer files in that way. Now, that being said, we don't have the ability to do syncing on the ACI file system. The way that our security protocols are, in order to be NIST 800 compliant, we're not able to use the syncing, at least right now, for either Box or Dropbox. And then there are some data-specific programs. Globus is typically between different HPC centers. Aspera is for, some genomics data. But there are some other ones that we can work with if that's something that you need specifically. So if you're copying a file, say one file, from your personal machine onto ACI-b, I would use the SCP, so it's secure copy, that's SCP. One file, my username, the host name, and then remember the tilde is the home directory. I didn't want to write out that whole thing, /work/period here. So that the period is going to that location within work. So again, SCP is just one way. There's a lot of different ways to do this. Yeah, so with WinSCP and FileZilla, and I should mention, so that the onboarding bootcamp slides, they're the ones that I mentioned before that have a lot of pictures about how to connect. They also have some more information. I just have this one picture with FileZilla and a little bit of information. But the bootcamp slides actually will go over this in a little bit more detail. But this is just the information that you need to get started. So you can use the SCP file protocol, use the data manager node. When you put in your username and password, if you put in port 22, it typically will bring up a little box asking you which Duo or which two-factor authentication to use. If the box doesn't pop up, it's probably going to, by default, go to whatever your first one is. And then this is, part of the FileZilla window, right? It actually goes all the way down here. But you're bringing up your storage on ACI as well as on my personal computer, and so I can drag and drop files very easily. So FileZilla is a relatively small program, but if you don't have administrative rights on your own computer, if you have a Penn State machine, you might have to have an IT person install that for you. All right, so the last part of this, getting up and going on ACI-b, is submitting a job. And I mentioned before that this is kind of the main focus of the second talk in this series. In that second talk, we're going to run a MATLAB script in 3 different ways. We're going to bring up MATLAB, very much like most people would do it on their desktop. We're going to run it as a batch process in the background, and then we're going to submit it as a batch job. So what I'm going to go over today is just a very high-level overview, so that way you know enough of the terminology to be looking around and you won't be completely lost if you want to get started before coming back to the other seminar in about a month. So within your submission script, and I have a sample submission script on the very next page, there's kind of 2 different sections. Okay, so the first section are the PBS directives. I talked earlier about how on ACI-b, when you submit a job, the scheduler is going to wait until you have enough resources to run your job on dedicated resources that aren't shared with anybody else. Now, in order to do that, we have to tell the scheduler what resources you actually need. And you do that with these PBS directives. So all the PBS directives will start with #PBS. There'll be things like the number of processors that you want to use, how many nodes you want to have this spaced out on, how long you want to run, if you want the entire node to yourself, what allocation you run on, how much memory you need, all of these different things. And so those PBS directives are only at the beginning of the submission script. As soon as the parser will come to some other command that's not a PBS command, it kicks out of it. So if you put a PBS directive at the very end of your script, it's not going to be used. Now the nice thing about the PBS directives is that for most people, once they get everything figured out, most of their jobs are pretty similar, and so you really only have to do that once before, after that you're just kind of making minor changes. Now the second part in the submission script are the actual commands that you're running. And the nice part about it is that the commands that you're entering here are the exact same as the commands that you would enter on the command line. And so when you're debugging on ACI-i, you're going to be doing the exact same thing. You'll just have not all the resources that you're asking for here and be able to do it in real time. So the other thing that's useful is that you have access to a whole bunch of PBS environment variables, right? So you have the environment variables that are set up because of Linux, because of what you have in your bash RC, and then also the environment variables that are set up by the scheduler when you're actually running the job. And so typically the commands are going to be something like load the modules you need, go to the correct location, because by default it'll just start in your home directory and actually run your code. And then when you have your submission script ready to go, you're going to submit it to the queue using qsub and then whatever the name of your submission script is. So most of the second talk will be going over some of the particulars here, but just so that you have an idea what you're looking at, this is a sample MATLAB submission script. Oops, I forgot a .bin here. So at the very top of this, you'll see a couple of lines that start with #PBS. So these are the PBS directives. So I'm saying that I want one node, and on that node, a single processor per node. I'm asking for a wall time of 5 minutes, and I'm going to submit this to the open allocation. And so those are all directives to the scheduler so that it can figure out when and where to run your job. So then after that, I'll do a couple of other things. I'm going to spit out the host name and whatever date I start at. I'm going to purge all the existing modules and load the version of MATLAB that I want. I mentioned earlier that you have access to the PBS environment variables, so I'm going to change to this PBS_O_workdir, which is a directory that I submit the job from. And then I'm going to do something. So in this particular case, I'm going to run MATLAB with no display, not bring up the splash screen. I think there's actually supposed to be a -bin here. I apologize for that. I use this input file, and I'm going to write the output to this log file. And then whenever the job is done, I'm going to write out the job ended at this date. So again, come to the next seminar if you want to know more details about this, but hopefully you have enough information that you'd be able to get started if you want to be doing things before next month. All right, so moving on. ICS has some decent documentation, especially for the onboarding, actually getting up on the machine, whether you're getting on with the terminal program or Exceed on Demand. I've mentioned a couple of times about the IASK Center. It's staffed by a couple of full-time people as well as a team of graduate students. And I would like to encourage you to take advantage of them. I worked there myself for about a year and a half. We get a lot of off-the-wall questions. Don't feel ashamed at all. You know, we've had some ones that are pretty crazy, and so I'm pretty sure that whatever you're asking, it's not going to be the craziest question we've heard. And again, Google is going to be a great friend of yours as you're learning, especially for getting around the terminal, getting around the command line. The command line is not something that's just Penn State, or that's not just ICS-ACI, so there's a lot of great resources out there. There's also some other good HPC centers around that have good documentation. TAC has a slightly different scheduler than we have, but their documentation nevertheless is very good. The Ohio Supercomputing Center has some good documentation. Something else that I'd also encourage you to do is look around at schools that do the type of research that you do. Right, so we may have 1 or 2 groups that do something, so it's not worth it for Penn State to do a whole lot of documentation for that specific thing. But some other school might have a whole bunch of groups that are doing it, and so they might already have a whole lot of documentation that's more specific to what you're actually working on. And so I would encourage you to poke around a little bit and see if you can find some good resources there. Now, I mentioned before that we have a second series in this particular seminar in October. The primary thing that we're going to be talking about is submitting this MATLAB job that I brought up before. We're going to actually run this MATLAB code in 3 different ways so that hopefully you'll be able to see how you go from a computer that you're sitting at with a GUI to be able to eventually run it as a job on ACI-b. We're also going to talk a little bit about compiling some simple codes. So we're going to do a parallel hello world code. We'll also talk a little bit about the allocation usage, right? So if your group purchases an allocation, you need to know how many hours you have left. Now, this is also very useful even if you aren't a part of a group that has an allocation, because you'll be able to look back at your previous jobs and see what you're doing. Especially if you're trying to track how well different processes are running, or if you're switching some things around, that'll give you some good data to be able to do or to make some of those decisions. We'll talk a little bit about some different methods of parallelization, both distributed memories, so that uses MPI, or shared memory, OpenMP. And then we'll also talk primarily about some data moving stuff, go over both Globus and rsync. We're going to be repeating seminars 1 and 2 in January, and then we're also adding seminar 3. So at the beginning of this talk, I talked about how there are NSF Exceed resources and DOE Insight resources. In order to get time on those, you actually have to write a little proposal. We can get you some starter allocation fund or core hours on those machines before that. And the purpose of that starter allocation is to be able to run some scaling studies and be able to show that your code is up and ready to go, and you'd be able to make good use of those resources. Seminar 3 is really going to be aimed at people that are looking at some of those bigger or other resources, not necessarily bigger, but other resources, how to write those proposals, the types of things that you need to know, as well as optimization. So we'll be talking a little bit about some different ways to optimize your code, and that'll be something that'll be useful for people that either are happy on ACI-i or are doing stuff and aren't writing Exceed or Insight proposals. So I think that those are scheduled right now for February of this next year. So for those of you that are going to come to Seminar 2, and I hope that you all do, that'll be much more interactive, right? Instead of me just talking at you, we'll go over a few things. We'll have 5 minutes for everybody in the class to do it, and we'll have some different ACIs or ICS staff walking around helping the people that need any help. So with that, when you come, please bring a laptop that has Exceed On Demand installed. We'll be using Exceed On Demand to actually bring up some GUIs, and so it'd be very helpful. And again, if you are using a Penn State laptop that you don't have administrative rights, you might have to talk with your local IT person to get that installed. Hopefully by then you'll have an account on ACI and have some basic terminal skills. You don't have to be a master by any means. I've been using Linux for almost 15 years and I'm still learning new things. But you need to be able to move around different directories. We'll be learning the MAM commands, and then also looking at some different qsub and qstat options. So even though you might be, at least seen those come up as you're going through some different documentation and starting to work on things, we'll be talking about those very specifically. So you don't have to be comfortable with those for Seminar 2 to work for you. And then also the ability to use some sort of terminal text editor. So I personally use VI. I know a lot of people use Emacs. There's some others that are available, but that'll be very helpful for you, both as a general skill as well as for this Seminar 2. So with that, thank you for coming. If you have any questions, I'd like to have kind of an open question and answer session now while we have the camera going. And then if you have any other questions that aren't necessarily for the greater good, we can talk about that afterwards. And I apologize, I should have done this at the very beginning. So I have 2 ICS staff members here. Justin in the back is one of our full-time people in the IS Center. He's a great technical resource. And then Julian up here, he's on our communications team. And so if I don't get to your question afterwards, feel free to ask one of these guys. So please, are there any questions? Yeah.
What's currently available at Penn State in terms of GPU resources, or anywhere,
That's a good question. Okay, so Penn State has some different GPU resources that are available to people that have purchased GPU or purchased that as a part of the CyberLamp partition. And then we also have some that are going to be available soon. They aren't going to be available as a part of the open queue, but that being said, ICS has what's called the Explore grant, and so you can, or try ACI, so you can request certain resources for a certain amount of time. The idea there is to make sure that it's going to work for you, so that way you know whether it's worth it for you to try to get one of those as a part of an allocation or not.
And follow up on that, if we were interested in purchasing something,
Yeah.
CyberLamp would be the place to.
Well, no, so CyberLamp was a kind of a one-off thing. They purchased their own group space, but we do have some other GPUs that are outside of that.
Okay.
So, yeah. Yes?
Does the ICS Center have office hours, or is it like an open door policy where you could go in and talk to somebody about specific questions?
Well, so the question was if the IS Center has an open door policy. Unfortunately, it does not. We actually live in the computer building, which is probably about a block directly that way, and you have to swipe to get in. That being said, we often have people contact us and we say, hey, can you stop by? And so we'll sign them in and they can come up and actually work with the person. But we don't have just open office hours to stop in. We've pushed for that at some different times, but we haven't ever been able to make that work. All right, well, if you have any other questions, feel free to stay afterwards and ask those. Anybody that came in late, if you haven't signed in, please do that. Thanks for coming. Happy computing.